Welcome to the second segment of TechMar's Snow Melting Training webinar series. This segment takes a generalized look at the methods with which a snowmelt system can be operated. We'll present you with the options, and you can determine which might be most suitable for you and your application. The outline for the presentation is to begin with the various modes of operation in a typical snowmelt system. Then we'll look at different ways we can start and stop a snowmelt system, followed by the advantages of having a fully automatic system. And the last thing we'll take a look at is the idling operation. So the three modes in most snowmelt applications are melting, idling, and off. Now obviously when we're melting, our slab is at a sufficient temperature that it is able to melt any snow that does accumulate on the slab. Idling would be a lower temperature so that the slab is ready to jump to a melting state should snow fall. And off would be we're not delivering any heat to that slab at all. Idling is generally a permanent state. So it's not something that we would start and stop on a semi-regular basis. It is something that would be in effect throughout the snowmelt season. Now one question is, how do we move between these states? So how do we go from idling to melting to off, or from off directly to melting? We'll look at those ways that we can enable and disable the snowmelt system. There are several ways to move between snowmelting states. We can do a temperature-based start, followed by a temperature-based stop. We can operate a system manually, so we start it manually and we stop it manually. Or we could start it manually and then have a timer so that it would stop after the predetermined set time. We can look at automatic methods as well, so an automatic start with a timed stop. And then the best of all of these would be the automatic start and the automatic stop. For a manual start and stop, it could look something like this, like you have a light switch in the garage maybe, and when you want to operate the snowmelt system, you flick the lever into the on position, and when you want it to stop, you would flick it back down to the off position. The advantages of this are that the user will control the melting cycle. So you know exactly how much melting you're doing because you're the person that's operating it. Another advantage is it's very inexpensive to install. However, the disadvantages can be extensive. You have to be on site to operate this. So if you're at work, you will have no way to enable your snowmelt system. Likewise, if you're asleep when it starts snowing, there is no one that's awake to flip the switch. So that's a major disadvantage with this system. I know myself, I used to have a manually start and stop operated snowmelt system, and what I found was if I knew it was going to snow overnight, then there were times when I would start the snowmelt system before bed. And then, of course, I'd have to stop it in the morning. So that would be running for maybe 8 hours straight. Now, the other disadvantage would be a risk of delayed stop, like I just mentioned, or delayed start. So maybe because we're at work or because we're sleeping, we're not turning the snowmelt system on in time. So by the time we turn it on, there's already significant snow accumulation on the slab that we have to overcome. The other disadvantage is the risk of an early stop. So you might think that the snowmelt system should stop, so you look out, there's no more snow on the slab. But there could be a lot of meltwater on the slab. And when you turn that snowmelt system off too early, that meltwater can refreeze and make a very unsafe scenario. So the manual start-stop, although you do control the melting cycle and it is inexpensive, it can lead to some pretty serious consequences. The manual start and time stop is one step better. So you're still controlling the melting cycle, and it is still an inexpensive installation cost. However, the benefit here is you don't have to remember to turn it off. It is on a timer. So you never run into situations where you turn your snowmelt system on and then forget entirely about it until you get your bill in the mail. So that would be a very terrible surprise that I'm sure has happened to a lot of people. So the timer avoids that scenario. The maximum typically you can set it to is 12 hours. So you do not have to remember that the snowmelt system is on. It will automatically turn off after the time has expired. The disadvantage is the same in that you still have to be on site. So you have to manually start that system. It doesn't help you if you're sleeping, if you're at work, if you're on holidays. In those cases, your snowmelt system just won't have a chance to turn on. The other disadvantage is it's very difficult to predict the amount of melting time that you need. What's the right amount? Should I set it to 6 hours? What if it's still snowing in 6 hours? Should I set it to 12 hours? Well, what if that was 4 hours too many? So you could be running your system longer than it needs to, resulting in higher operating costs, or not long enough, resulting in dangerous conditions. You could also go for the temperature start and stop. So this would be once we drop below a certain temperature, maybe below freezing, our snowmelt system is on. And it doesn't turn off until we are above freezing again. So the advantage of having a system like this is there is no snow accumulation. Our slab is always warm, it's always ready to melt. The disadvantage is that this method uses a lot of energy. So it's on for the entire snowmelt season, and typically it only snows for 10% of the days where we're below freezing. So for the other 90% of the time, we are just wasting energy. And of course, this means that we're operating with a dry slab. So our snowmelt system is running even when there is no moisture on the slab. So this would be a very expensive alternative. However, in some cases, you might want to operate this way if you care more about safety than the operating cost. We have an option to do an automatic start and a time stop. So this would be some kind of detector like the one shown in the image where snow is detected and automatically our system is started, so a melt cycle is initiated. However, we're looking at a timed stop. So it's not an automatic stop, we have a timed stop. Now there are definite advantages to this. It is an automatic start, so even if you are asleep or at work, your snowmelt system can work when needed. Of course, the disadvantage to the time stop is what we talked about before, in that it is difficult to predict most efficient length of melt cycle. Our other option would be for automatic start and stop. So in this case, we would have a sensor that would detect moisture to initiate a melt cycle, and it would also detect when the sensor is dry, and in that case we would automatically stop the melt cycle. So there's no predicting in this scenario. The sensor has the intelligence to operate the system when we need to have it operated. Because we have two different automatic start methods, we have the automatic start with the timed stop, and we have our automatic start and automatic stop. Because of these options, we introduce the question of how do we decide which one to choose. So we're going to look at when you would choose the automatic start with the timed stop. And the obvious application would be like the one that we've shown here in the image, is where an installation has begun and we've poured the concrete before installing the socket. Many of you might be surprised of how often this does happen. In situations like that, where our only alternative would be to core the cement to try to achieve that sensor installation after the fact, which is a very expensive venture. Having an automatic start and time stop would be another alternative to still gaining some automatic operation at least, but it gives us an alternative in situations where we do make that mistake. The other scenario where we could use this type of operation would be for retrofits. So in applications like my own that I talked about earlier, where I did have a manual on-off switch in my garage, That's a perfect scenario for wanting to update your system to include automatic operation. So in my case, it involved installing a 654 control and then installing the automatic start and time stop sensor for that type of operation. So those are the two main scenarios where we would advise you to consider this type of operation. But of course, the automatic start and automatic stop is your best bet if that's available to you. So what are the advantages to having the fully automatic start and stop? Well, it's definitely more convenient. There is no human operator required. The system will automatically start when it's needed and automatically stop when the moisture is gone. It's more reliable because the system operates when it should. So we're operating at the first signs of moisture, and we operate until there are no more signs of moisture. Of course, that will also translate into greater safety. We continue the melting cycle until the slab is dry, so we avoid the chance of a refreeze. And maybe one of the most compelling reasons for most people is the energy savings. We are only operating our system when snow or ice is detected. So we're operating for the right amount of time under the right conditions for snow or ice. So that means when we're not operating, we're saving energy. We mentioned idling earlier as one of the snow melting states. And what we're going to do with idling is preheat the slab, and we'll keep that slab below freezing, but high enough so that when snow is detected, we can quickly respond and bring that slab up to the appropriate temperature. Now, we would do that in areas where safety is prioritized. So hospitals, vehicle ramps, helipads like we've shown here, where we want to melt snow quickly and avoid snow accumulation. Now, the degree of idling will depend on what we call the snow-free area ratio, and we'll look at that on the next slide. There are three levels of the snow-free area ratio. We have AR0, AR.5, and AR1. And for those of you familiar with the former class system, this is what has replaced the level 1, 2, and 3, or class 1, 2, 3. So AR equals 0 would be the entire surface may be covered in snow during melting. Okay, so even though melting is occurring under the blanket of snow, the entire surface may be covered during that process, and the snow will gradually melt after the snowfall ends. So applications for this would be residential type applications, and in this case we are not doing any idling because idling is expensive. And for residential applications, most people want to keep costs as low as possible and are not interested in idling the system to make sure there is zero snow accumulation. It is not a priority, it is not essential. So in this case, idling would be turned off. If we have an AR of 0.5, what that means is that 50% of the surface area can be covered with snow during the snowfall event. And the remaining snow will of course gradually melt after the snowfall ends. Now this would be recommended for commercial applications such as docks, ramps, entrances, and driveways. Could be used in residential applications if it's very important to the user that snow melt quickly. In this case we would idle the system, but it would be at a lower temperature, so maybe mid-20s. The next level, the highest level, would be an AR of 1. And what that means is absolutely no snow accumulation is allowed. So this would be recommended for hospital emergency entrances, helipads, or high priority aprons, loading areas, runways, etc., where it is critical that there is no snow or ice accumulation. And in this case, we're melting all of the snow at maximum snowfall amounts as the snow falls. So we'd be idling at higher temperatures, probably right around freezing, perhaps 28 to 30 degrees. So to take a look at a comparison here for the snow-free area ratio. On the left-hand side, we're showing a residence, and we can see there is snow accumulation on the slab. The snow is falling and is not melting immediately. That would represent your typical AR of 0. If we look to the right, we can see a hospital entranceway. And in this case, there is no snow. This is a critical safety area, so the AR would be 1. In summary, this presentation went over the different modes of operation for a snowmelt system. So we looked at the various start and stop methods. We looked at the manual start and stop, the manual start and time stop, temperature-based start and stop, which would be the expensive operation where our snowmelt system is operating whenever we're below freezing. And then we looked at the 2 different ways of having an automatic start. So we can have an automatic start and the timed stop. And we looked at the automatic start and stop. And because we have those 2 different ways of automatic enable, we took a look at when we might choose an automatic start and timed stop. And the situations we recommended would be if concrete is poured before the socket is installed. So it would give you at least an option for having some automatic operation, even though it wouldn't be possible to install the automatic start and stop sensor. The other type of application where it would be recommended would be if you're retrofitting an existing system. So you're going to add Snowmelt Control 654 with the automatic start and time stop sensor. So that you can move away from the manual operation and gain at least some degree of automatic operation. We also looked at why it is advantageous to have a fully automatic system. So what are the benefits of having the fully automatic start and stop? And then we looked at idling, so the cases where idling would be desirable. And we looked at the different snow-free area ratios that will typically stipulate what degree of idling is necessary. Now this training segment contained general information about how to start and stop a snowmelt system. If you're looking for some more particular information of how a TechMar system will operate, then please take a look at segment 3 of this webinar series, and that segment will go over the TechMar snowmelting controls and sensor options, and we will look at how each of those different options will lead to different control points.